Hi, I'm Ashik, and today we're going to look at CQRS and event sourcing and how to do CQRS and event sourcing with ASP.NET MVC and NCQRS. This is a re-recording of my session at mvcconf2. I needed to record it again due to some technical difficulties with Camtasia, live meeting, and a certain HDMI connection between the computer and the monitor. So without further ado, let's take a look at today's agenda. First, we're going to be looking at a very simple ASP.NET MVC application that uses these concepts. We'll then look at what CQRS, event sourcing, and NCQRS is. We'll discuss what benefits these patterns give us over traditional applications. We'll discuss a few problems, and lastly, I'll answer a few questions that came up during the presentation. CQRS stands for Command Query Responsibility Segregation, and this is a typical architectural diagram of a CQRS-based application. Now, as you can see, the line down the middle separates the application into two distinct segments. The side on the left is used for writes or updates, and the side on the right is used for reads or queries. The user interface queries a denormalized data store for the exact data it needs to display stuff to the user. And whenever the UI needs to change something, it creates command objects. Commands can be thought of as requests for something to change, and these commands are put on a bus. The bus triggers certain methods to be called on domain objects, and domain objects do business logic processing and generate events. While commands are requests for something to change, events represent something that has already happened and changed in the past. These events are put on an event bus, which carries them to any and all denormalizers that have been registered that handle that event. These denormalizers are classes that update the denormalized read model based on the event that has occurred. Let's take a quick look at an ASP.NET MVC application that uses NCQRS. I'll quickly launch the application. It's a very simple contact manager that just manages names. It's got a create form, and if you try to create a contact without providing a name, it gives you validation errors. Let's create one called John, and let's create a second one called Stuart. And we can also edit, so let's change John's name to Scott. Right, and that's all the application does. Let's take a look at the source of the application. We'll start off at the contact controller and the create action. When we want to create a new contact, we want to issue a command of type create contact command. This is a very simple DTO-like object which has two properties. One's a GUID for the contact ID and one is a string for the name. You can see that I have data annotations attributes on these properties, signaling that the name is required and also that the contact ID should be put in a hidden input variable. We'll take a look at what maps to aggregate root constructor does in a moment. If we look at the create form, views create, you can see it's quite simple. It has a validation summary, it has a form, it is using HTML editor 4 to display the form, it has a cancel button and a submit button. You'll notice that the type of the model is of type create contact command. This form is submitting a create contact command. So when this form submits, the post create action gets called, so this one here, and over here we are issuing the command a new ID. We're checking if the model state is valid. If there were some sort of validation errors, this is where they'd get caught on the client side. And I'd actually call this the client side, even though this is a controller, since there's no business logic validation done here. It's only the command that's getting validated. If the model is valid, we are calling execute on a service, which is of type iCommand service. This is getting injected into the controller's constructor. Right. If there are errors that happen during execution of the command on service, we are adding an error to the model state, and if there is an error, then we simply redisplay the create form with the validation errors. If not, we redirect to the index view. And let's now take a look at the index view. All the index view is doing is it's calling the getAll method to get on the read model store to get all the instances of a contact summary, and it's passing it to the index view. Let's go back to the service execution of the command. When the command is passed to server.execute, what happens is NCQRS takes that command, looks at its attribute over here, and takes an appropriate action. Now this has the attribute maps to aggregate root constructor, and the type that's passed in is type of contact. What NCQRS does is it looks at the properties that are present on the command, and it looks at the type that's passed into the attribute, and it calls the constructor of contact that has parameters contact ID and name. So if we go to the contact, you can see it has a constructor that has the first parameter called contact ID and the second parameter called name. Now this is our business logic class. This can do additional validation, and when it's verified that the command, contact can indeed be created, it generates an event. Remember, an event is something that represents something happening in the past, something that's already happened. So while a command can fail, an event once generated cannot. It's part of history. Right, so after generating the event, it applies the event. Applying the event tells NCQRS to save the event to an event store. We'll come to what that is later. And it also puts the event on the event bus. As far as the aggregate is concerned, i.e. the contact, this method gets called. The reason this method gets called is that contact is an aggregate root mapped by convention. The convention is whenever an event is applied via apply event, a method that is called on that event without the word event is called, passing in the event. So if this were something called, say, X happened event, a method called on X happened would have been called, and the X happened event would have been passed in. Now, notice that over here, we are not doing anything on the onContact created. The reason we're not doing anything is that, as far as we're concerned, at this point, what value the name has does not dictate any business operations on part of the contact. If it did, we would have probably stored that value in the onContact created handler. Right now, that's not the case, so we're not doing anything on the onContact created. Although we do need this method to exist, because since contact is an aggregate root mapped by convention, NCQRS is going to look for this method when apply event is called. Now, that said, when the event gets pushed on the event bus carries that event to any and all denormalizers that have been registered. Now in Bootstrapper we have registered a denormalizer to handle that event. So if you go to the read model project, you can see we have a denormalizer that handles two events, one of them being contact created event. Now when the contact created event gets put on the bus, the handle method is called that takes in a parameter of context created event. Now this is our denormalizer. This is supposed to respond to events and update the denormalized read model so that future queries get the updated state of the read model. As you can see, this is very simple. We have a context summary object, which, by the way, we are using Entity Framework Code First CTP5 for our persistence of the read model. So the context summary has pretty much the same properties as the command and the event had. Although till now you can see that the command, the event, and the read model table has the exact same properties. That's not always the case. In more complicated scenarios, you could have a command that generates multiple events. You could have commands that generate events that have different properties. These read models could be vastly different from what the commands and the events look like. But the thing is, the denormalizer is the guy who is charged with taking in the event and updating the read model, which we've done through the read store over here. So we've added the new context summary object and called save on the store. And that is one complete cycle of the create. You might have noticed that our create context command inherits from domain command, and domain command inherits from command base, which is an NCQRS class. And all we're doing in domain command is we are specifying a buddy class over here, and in that buddy class we're just saying that the command identifier should not be scaffolded in the view. If we did not do this, we would have actually seen MVC generate text boxes with GUIDs or labels with GUIDs for the command identifier in our create and edit forms. Now, unit testing all of this is pretty straightforward. If you look at the context controller, we're just taking in a iCommand service and read store by the constructor, and when creating a new command we're just calling service.execute, and pretty much for all commands we'd be calling service.execute, so there aren't a lot of things to mock to unit test this. If we look at our contact class, all that's doing is it's taking parameters and generating events, and as such it's very easy to unit test business operations in the domain. I've written a single unit test for this, for contact creation, and well, I'm using mspec here, but you should be able to make out what's happening. We have initialized a few things over there, and we're saying that when a new context is created, we're fetching what uncommitted events are there on the contact object. We're then verifying that only one event has been generated. We're then verifying that the event that's been generated is a context created event. We are then ensuring that the event that was generated has the contact ID and the name that was passed to the constructor. Now notice that in this method we can verify that everything that we wanted to did happen, and we're also ensuring that no unwanted side effects took place. For example, if something else happened accidentally, it would generate more than one event, and this test would catch that. So in other words, we can confidently unit test that everything that we want is happening, as well as ensuring that everything that anything that we don't want is not accidentally happening. If we go to the denormalizer, you can again see that this is just using the read store, and read store is an interface which we can quite easily mock during unit testing, so you can also easily unit test all the denormalizers. Let's now look at editing a contact. So in the edit action, the get one, the contact ID of the contact edit gets passed into the action. We query the read store for that contact summary object. We're then using automapper to map that contact summary to an update contact name command. And if you see the update contact name command, it is a separate command from the create contact command. We'll look at how this differs from the previous one in a moment. So we're using automapper to map that contact summary to the update contact name command, and we're passing it off to the edit view. The edit view is pretty much exactly the same as the create view. So there's the validation summary, form, editor, and submit. No changes there. When this gets submitted, you can see that we're again checking if the model state is valid. If it's not, or if there's an error, we send back the edit view, giving it the command that we took as input. And if the command is valid, we call service.execute just as before, and then we redirect to the index view. We could have probably refactored a lot of this using user controls and everything. I just wanted to keep the demo as simple as possible. Now when service.execute is called passing in the update contact name command, what NCQRS does is it looks for the attribute on update contact name command, and it finds maps to aggregate root method. Now notice that this differs from what we had with the create command, where it says maps to aggregate root constructor. Now when maps to aggregate root method is found, NCQRS looks at the type of aggregate root where we've passed in contact, and it looks for a property with the attribute aggregate root ID, which is contact ID. So what NCQRS will then do is fetch the appropriate contact instance with its current valid state that has the matching contact ID, and then it will call a method called update name on that instance. Okay, and it will pass in the values of parameters that are not the aggregate root ID. So in our case, all that command is doing is just fetching the correct contact instance and calling update name on that instance, passing in name as the value of the parameter name. So if you look at that method, you can see that update name, there's a method called update name that takes in a single parameter of type string called name. Okay, this again does some business logic validation if it needs to, and then it generates an event. And that event is again pretty much exactly the same as the create event, but since creating the event is different from updating the name of creating the contact is different than updating the name of a contact, we have two different events. As before, the generated event is put on the bus via apply event, and on contact name updated gets called. At this point, we still don't have any use for the value of the name in business logic processing, so we're not saving this anywhere. What NCQRS is doing is it's seeing that the event was placed on the bus, and it is triggering the handle method in the denormalizer that handles that event. So you can see we have event handler contact name updated event implemented by contact index view denormalizer, and as such this method will get called. And here what we're doing is we're fetching the contact summary from the read model, we're updating the name and simply calling store.save. This will update the read model based on the change that has occurred, i.e. based on the event that has been fired. So subsequent queries to the read model would give the updated state. Let's go back to the contact aggregate route and say we have a new business requirement where the contact name updated event is only going to be fired if the name does not match the current name of the contact. So in this case we do need to maintain the state of the contact's name, and we do this via a private field. Let's call this string name, and we need to set this when a new contact has been created, and these state fields only get set inside these event handlers. They should never be set in the command handlers or the constructors. So in the event handler for created, we can then say name equals at event.name. Similarly for the updated, we can say underscore name equals event.name. And lastly, in the update name, we can then say if underscore name equals name. So if it's exactly the same, we simply return without raising an event. As such, if the name, if update name is called, passing in the same name as presently there, this event would no longer get generated, and all the denormalizers would need to get updated. For now, let's leave that out. That's pretty much it for the demo. We'll just go into the database and see what it looks like. The event store is a database that's created with a SQL script called table creation script. It's part of the NCQRS source code. Currently it generates 4 tables. We're only interested in 2. The first one is event sources. This has 1 entry per aggregate instance. So we created 2 contacts, so we have 2 of them. There's a column called version number. Whenever an event is played on a aggregate root instance, its version goes up by 1. So remember, we edited 1 contact, so that has version 2. The created was version 1, and then the edited was version 2. For the other aggregate, we didn't really edit it, so it still has version 1. The other table is that we're looking at right now is the events table. It represents each event that's ever happened in the application. You can see that it has a timestamp, it has a name to represent what type of event it is. It's also got a version number, but we won't go into that. It has a sequence number, which is used in playing back all events or a subset of events on an aggregate instance in sequence. Again, we won't cover that. It has an event source ID, so it can find out which aggregate instance the event should be played on. And it has a data column where the properties of the event are serialized as JSON and stored. So if we look at that in Notepad, you can see it has a contact ID and a name of John. We created 2 aggregates and edited 1, and as such you can see that there are 3 events in the event store. if we look at the Contact Manager read store, you can see that it currently has two tables. This was generated with Entity Framework code for CTP5, as such it has an EZM metadata table. The table that interests us is the contact summaries, and you can see that it has the contact ID and the name. And all UI queries are done against this table. Let's go back to the slides. Right, as I said, CQRS stands for Command Query Responsibility Segregation. Queries fetch data, commands change state. All queries are side effect free. Queries read from a denormalized data store. Now the reason they read from a denormalized data store is that normalization in databases is mainly for achieving referential integrity. That kind of ensures that all data is consistent in the database. Now, the concept of referential integrity is useful when data is updated or changed. There is no use for referential integrity if data is only read and not changed. As such, the concept of the whole domain model and referential integrity, all of this is for the commanding side, not for the query side. As such, CQRS uses a very simplified, flat, denormalized database to fetch data from, and it handles all the things related to editing, maintaining referential integrity, etc. on the commanding side. You can get more info on CQRS at cqrsinfo.com, which has loads of resources, links to articles, projects, etc. And, well, it's brilliant. Back to our diagram on CQRS, you can see that the read model is persisted via a flat database table or a NoSQL document or something. So where does our domain get persisted, and how is it maintained as being consistent? Well, one way of achieving this would be to have a second database which would be relational, which would have relations, which would enforce relational integrity. And when a command comes in, you would query the relational database for the domain object, and that would generate events, updates. You would update the state, etc. That's one way of going about it. The other way is event sourcing. Event sourcing is a method by which every change or event that has ever occurred in an application is stored somewhere. And these events are propagated to various clients. Now, this is one way of achieving persistence of the domain. How this is done is that when a command comes for a particular aggregate root instance, CQRS creates a new instance for that aggregate root type, and then it fetches all the events that have ever occurred on the target aggregate root and plays them back on the newly created instance. When all of the events have been played in sequence, the aggregate root comes up to speed, if you will, and its state reflects the current state of the aggregate root object. Now this might seem slow, and one way around this is to use something called snapshots, which uses a memento pattern to take regular snapshots of the aggregate root object. So when a new command comes in, only the snapshot is loaded, and then only the events after the snapshot are played back to bring the aggregate root object up to speed. This is something that can entirely be handled by the event store, and if you're using CQRS, you get this for free because it's already in the framework. Now, all changes are saved when doing event sourcing, so newer changes don't blow away older changes. In a traditional application, if you have a person table which has a name column, and a certain person has the name John, someone comes in and changes the name to Joe, and then someone comes in later and changes the name to Adam, all you'll be able to retrieve is that the name currently of that person is Adam. You would not be able to tell that it was changed from John to Joe to Adam or whatever. Now, if you wanted to retrieve that historical data, you would have to manually create and implement an audit log. This is not simple if it's not been built into the initial design of the application. Due to the way event sourcing works, you have all the events always, so you get a free audit log. This also makes going back to a certain point in the past and playing back events quite simple. For example, if you were to replicate a certain scenario that happened at Friday night 10 p.m, you'd go back, you'd play the event back from snapshots until Friday night 10 p.m, and then you would play the next event that occurred. So you'd essentially be able to go back in time in that exact same scenario and debug what exactly happened in your domain that caused an application failure or some bug or something. So these scenarios can be really difficult to target in a traditional relational database backed application. NCQRS is an open source CQRS and event sourcing framework built with .NET. You can find more info on it at ncqrs.org. It's easy to extend. It comes with SQL Server, SQLite, RavenDB, and MongoDB event stores. It's easy to integrate with nService Bus. It has convention, attribute, and fluent interface-based mappings. We only looked at the attribute-based mappings today, and it's got snapshot support. The main benefit of using NCQRS is that it takes most of the framework away from the application developers. So, handling the event store, handling the buses, sending events to denormalizers, all of this is taken care of with NCQRS. And that makes it very easy to get started with CQRS and event sourcing rather than trying to implement the whole bus, command bus, event store all by yourself. We've already looked at an ASP.NET MVC application that uses NCQRS, and in order to use NCQRS with ASP.NET MVC, what you would have is you'd have read models that have tables or documents if you're using NoSQL to serve as view models for pages that simply display data. In a typical ASP.NET MVC application, what you do is in the controller or the application service or somewhere, you fetch data from the database, and then you do projections on it, joins on it. You throw away some of the data that you retrieved because the object relational mapper retrieved too much data that you didn't need, and then you put all of this data into a view model, pass that view model to the view. Now you do this on every single request. With a CQRS-based application, what you do is the denormalizer essentially creates that view model thing in the read model. The controller simply queries that read model to get the data it needs, exactly the data it needs, nothing more, nothing less, and then displays it via the view. Any view that needs to change something, so do an update, delete, or create, that must submit a command. As such, the model type for that view will be of that command. Now, we are getting read data from the read model, so we're not getting commands. So what happens for something like updates? For updates, what you do is you'd get that read data, you'd use AutoMapper to map that data to a command, and then pass that command over to the edit view. Since the only things that get submitted in post are commands, you can have validation attributes and data annotations attributes on the command objects themselves. As such, you'll get all the rich MVC behavior that can be got via these attributes. For example, validation, client-side validation, HTML form creation, etc. You'll get all of these features on the commands out of the box. You might have noticed that in our demo application we did not really have any command-specific input tags or text boxes or whatever. What we just went html.editor4 and ASP.NET MVC, based on the attributes we'd put on the commands, actually generated the form for us. The post actions can mostly use the default model binder, so take the stuff from the form, data from the form, and then bind it to the input parameter to the post action. In most cases, you should be able to use that just as is. If you're doing something like file uploads or something, you would probably need to write some code to map those things to the command objects, but that would be pretty trivial compared to what we had to do with traditional applications. A typical ASP.NET MVC project has many components to it. There's obviously the model, the view, the controller. Then you get the ORM, the repository, the specification pattern, lazy loading, domain, database, unit of work. It just goes on. And you have to kind of be aware of all of these things in the back of your mind when you're doing anything. And what this leads to is that it can get very confusing about what should do what. Business logic can kind of seep into services, resulting in an anemic domain model, where your domain objects are basically bags of properties, getters and setters, that carry out no business operations, and the only thing they resemble to a domain object is that they are named after stuff in the domain. Most operations are reads in the majority of applications, and the writes are quite few. Having a normalized relational database as the only persistence medium results in slower reads due to repeated joins. The relational integrity of a relational database only comes into effect during updates, creates, or deletes. When simply querying data, the relational integrity is useless. We already covered this before. ORM-specific code and concepts can leak into sections outside the repository. These repository abstractions can kind of be leaky. Say how you are going to filter your queries via a specification pattern, how you're going to handle stuff like lazy loading, pagination. All of this can be very difficult to completely abstract away from the application code. As such, you might have application code that is quite dependent on a particular ORM, while you might not really want to switch ORMs, at least not in the near future, what you might need to do is have a lot of setup code during your unit tests, and that's possibly something you won't desire. Domain models can have their data exposed in a typical relational database-based application. By that, what I mean is that other parts of the project will know what the internal structure of your domain object is. So, say if certain relations or classes in the domain change, any application class needs to immediately change their code. Needs to change its code to update itself. Otherwise, the application will be in an unusable state. So if the structure needs changing, it can be a major change where other applications would need to be updated immediately before they can be usable. In a CQRS-based solution, the domain is completely shielded from the outside world. The only thing the outside world knows about the domain is the commands that can be issued upon it and the events that the domain generates. As such, we are free to change the implementation inside of the domain that can control how commands are handled and how events are generated. At a later date, the denormalizers can update themselves so that those changes are, rather the changes in practice are reflected in the read model. Same goes for the UI. As such, different teams can work in parallel, and changes in one section does not necessarily mean that everything has to update immediately before the application becomes usable again. In a typical ASP.NET MVC application, it can be very difficult to implement an audit if it was not part of the original design, and even if it was, you would still have to implement it yourself, whereas with event sourcing you get all of that for free. As we mentioned earlier, in a traditional application, new changes would overwrite older changes, and older changes would be lost forever, whereas with event sourcing you would be able to go back and see every change that has ever happened. A typical application would require a least common knowledge for the whole of the dev team, and this knowledge would involve technical as well as domain knowledge. If someone did not have sufficient technical or domain knowledge, they may cause delays or inconsistencies. Throwing more devs on a project would not increase productivity. There would be some time needed for the dev to come up to speed on development practices, technical stuff, as well as business logic itself. While throwing more devs on a CQRS-based project will not necessarily increase productivity, it might very well do so. If we go back to our CQRS diagram, you can see that we have three colored shapes. The one on the left, this is the domain model, and the domain developers, all they need to know is what commands are coming in and what commands are going out. Once that's been established, they're free to implement the domain model in however way they see fit. The denormalizer guys, what they need to do is they need to consume events and update a read model, and that's all they have to do. The UI guys, they read from the read model most of the time, and when they need to change something, they simply issue a command on the service. That's also something that's completely separate and repeatable. You're basically introducing repeatability in your application. So if you see that the domain model is going okay, but the denormalizers aren't getting updated as frequently as you want, and I'm talking about source code, not runtime performance, obviously. So if the development of the denormalizer seems to be slow, you can actually throw more devs at it, because all a denormalizer has to do is take in an event and update the read model. Similarly, you can throw more guys in the UI and expect an increase in productivity. You could potentially also throw more guys at the domain, but they would need a level of business logic before they can contribute properly. That said, the technical knowledge needed is pretty much compartmentalized. So this guy doesn't really need to know how the read model's working. The denormalizer guy doesn't need to know how events are being generated, and they can actually contribute to these sections without knowing how the other sections work. On top of that, the event bursts, the command bursts, the underlying architecture things, attributes you create, or handlers you create, or executors you create, these are only needed once. Once you've had once you've created them for one project, you can reuse them in pretty much every single project that you do. So you're introducing repeatability, you're introducing reusability of a lot of the practices and components in your system, which isn't really that easy to do in a typical architecture. One more thing is that it's possible to test that what we want has happened in typical application, but it's very difficult to test if there's been some unintended consequences. With CQRS and event sourcing, the domain model or the domain objects in your application come down to simply taking in parameters and generating events. And as such, you can ensure that a certain number of events of certain types are being generated, nothing more and nothing less. So you can prevent unintended consequences in the domain at the unit test level rather than at the integration test level. There are a few things you need to watch out for when you're using these technologies. The first of which is that this is a paradigm shift. People are used to using relational databases to represent their model. If they have, say, persons in classes in a school, in a department of a school or something, they would expect to see a person table linked to a class table, linked to a department table, linked to a school table. Especially with event sourcing, you would see that the actual thing holding the domain data is just a stream of events, nothing else. On the read model side, the database is denormalized. We've pretty much always been taught that databases should be normalized to maintain integrity. Whereas this is doing completely the opposite. The integrity is being maintained in the event stream or a separate database, whereas the database that the application is querying from is a denormalized database with lots and lots and lots of duplication and no referential integrity. NCQRS is open source. It does have bugs here and there. If something doesn't work, you can quite easily change it. The source code is quite good and it's extensible. If you have a problem, you can, and you're kind of competent with C#, reflection, and lambdas, you should be able to figure out what the problem is. You could even contribute back. It is open source, and I'm sure the guys would appreciate any contributions you can make. CQRS and NCQRS is definitely not a silver bullet. There is no such thing as a silver bullet. This is definitely not something that's going to work in 100% of applications, but it can be useful for a lot of applications. Lastly, don't trust the NuGet feed for NCQRS. It is out of date. It does not, well, last time I checked, it did not work. I think referenced a wrong version of JSON.NET or something. Right. If you are going to be developing with NCQRS, please get the source for the def branch and compile it yourself. Don't get the source for the release branch at this point. The dev branch has lots of bug fixes and stuff that you might run into otherwise. I'll quickly go through the questions that were raised during the mvcconf session. The first one was, can this be used with POCOs or plain old CLR objects? Out of the box, NCQRS does not support POCOs yet. Simone has spiked a branch, and this is something that looks like is going to get integrated into a future version of NCQRS. Another question that was raised was, what sort of applications can use this type of architecture? Well, the obvious ones would be any application that requires a audit log would get it free if you're doing event sourcing. Another type of application would be those that require a certain level of scalability. Since your read models are feeding your queries directly without any need for projections, that would significantly increase performance. On top of that, you'd be able to store some parts of the read model on one machine, other parts of the read model on a different machine, and depending on your load, that might increase your scalability quite a bit. Commands are going to be slower, obviously, because they have to go through a lot of processing. But again, in applications that require that level of scalability, usually updates are slower than reads. For example, even in applications like, say, Google Groups or Facebook, or even Twitter, when you submit something, it usually takes a while before the change is propagated to the UI. And while I do say commands are going to take longer, usually that longer bit is in the terms of milliseconds. So instead of taking, say, 20 or 30 or 40 milliseconds, it could probably take 200 or 300 milliseconds. But most of that would not even be from the command to the domain. It would be from the event store to updating all the read model tables via the denormalizer. So in those cases, you should be able to use async event buses, and as long as the domain is updated quickly, the rest being, say, a couple of hundred more milliseconds shouldn't really matter that much. Another type of application that can benefit from event sourcing are those that need to represent different models to different people or applications. So say you have an application that needs to cater to different departments in an organization, and each department kind of expects a different type of model. This would be quite difficult to achieve with a single relational database based implementation. You'd probably have different services or web services looking into the same database and trying to filter out the data that it needs to return, and that can be significantly complex. With event sourcing, CQRS and event sourcing, what you'd have separate sets of denormalizers that would process the events and create truly separate models for the different departments. And so it would be easier, much easier to keep everyone happy. Personally, what I find most useful about CQRS and event sourcing is not the scalability or the audit or any of that. What I find most useful is that it simplifies the application. It compartmentalizes different aspects of the application into separate areas. It draws clear boundaries that are only crossed by DTO objects, namely commands and events. The UI developer knows his boundaries, the denormalizer guys knows their boundaries, domain developers also know their boundaries. So one member of the team doesn't have to know about the entire dev stack or the whole business knowledge of the whole application before being able to contribute. And as such, you won't, it's less likely to have a scenario where if one developer leaves, you lose a ton of business logic along with him, or application-specific logic along with him, because most of the technical stuff is pretty much explicit, be it the domain code, be it in denormalizers, be it in the user interface. Another question that came up was if anybody was using this in the real world. Now, the concepts of CQRS and event sourcing and denormalizing commonly read data is pretty common and is used in many scalable applications out there. You can quite frequently notice applications, websites anyway, that if you post something to it, it can take, say, a few minutes or something to update it in the user interface. So that's using some of these concepts. As far as NCQRS goes, this is kind of a new framework. It is being used by some applications out there. Some financial applications are also using it because of the audit lock capabilities and for the simplification of the application. We used the NCQRS with the prototype application a couple of months ago, and now we are using it in a much larger application that will consist of data being used throughout the entire organization and even being made available to the public. If you are looking to use this in one of your projects, little word of caution though, you might see that a certain requirement that you have does not is not met by NCQRS out of the box. For example, in one of our applications, they had integer IDs. Integer IDs are not currently supported in NCQRS, so we had to write a kind of extension-like thing that would allow the denormalizers and the read model and the UI to deal in terms of integer IDs while giving NCQRS and the framework and the domain objects their GUID IDs. And the funny thing was, we implemented quite a robust solution for this, and it took less than half a day to do. Once done, we haven't had to touch it, and it's been working fine ever since. So usually, if you are good with C#, reflection, and a bit of Lambda syntax, you should be able to bend NCQRS to meet your requirements. One of the questions that frequently pop up is if this is a replacement for DDD, or domain-driven design. I'd like to think of this as more of an evolution of DDD rather than a replacement for it. A lot of the concepts in DDD are even more forceful in CQRS and event sourcing. For example, when I was reading Eric's book, one of the things that stood out to me was that different contexts should not be sharing code apart from translation DTOs. In a typical relational database-backed application that has your domain objects backed by the relational database, you do your business logic processing in the business logic context, in your domain context, and you also send these domain objects to the controllers, which is part of the UI, or to services, which is part of the UI, which may get translated to view models or DTOs or something. The fact is that controller or that service is still coupled to a specific structure of the domain. So you are essentially sharing code between contexts that are not translation DTOs. Okay? In CQRS and event sourcing, this is not possible because the domain is completely isolated from the rest of the application through commands and events, and these are simple DTOs, translation DTOs. They don't carry any specific structure with them. Another concept in Eric's book was that implicit concepts should be made explicit. In a typical application where you retrieve your domain objects from the database, project them to view models, send them to the view, handle business logic and everything, all of these concepts are kind of implicit, and as such different developers can interpret them in different ways. Someone might do business logic processing through a certain service. Another dev might find that he's doing it directly through a repository. A third person might see that he needs to do it through a service, but he can't seem to understand which service is being used for an update, so he creates his own service. So at that point you can have two services that are pretty much doing the same thing, and it can be difficult. It's not impossible. Proper design and everything can obviously help, but it can be difficult to maintain these rules or conventions in your application for a long period of time. For example, I've seen application code that have had business logic in JavaScript. I've also seen application code that has hundreds of lines in model binder code, and the model binders are using reflection. They are using, they're doing business logic processing. They're doing a lot of things that should not be done. And I guess these applications also started off pretty cleanly. You can see that it has separate repositories, services, and everything that you commonly associate with TDD. But the thing is, since these concepts were kind of implicit where to do what, they ended up being processed in the view or the model binder or JavaScript, which I don't think the original developers intended. With CQRS and event sourcing, these type of concepts become explicit. An aggregate root is confined to taking taking commands and generating events. A denormalizer is confined to taking an event and updating a certain set of read models. The user interface is confined to reading in data from the read models and displaying it to the user, and capturing user input and sending that via commands to the aggregate objects. So all of these are defined explicitly. Even if you wanted to, you could not break this chain. And any deviancies from this kind of pattern would be immediately recognizable. So with CQRS and event sourcing, it is far easier to make implicit concepts explicit. One more thing in Eric's book was about maintaining aggregate integrity. Now, if we have our domain objects that have property getters and setters, and that expose the relations they have with other entities and stuff, in that case, our UI code, the controllers, the views, and if we're using web services, then the clients of that web service would know about this specific structure. It would know how the aggregate is built up inside. Okay, you could kind of shield that part by using view models, but then you would have to actually map it as well. And still, maintaining the aggregate integrity would be considerably difficult. I mean, if a contact has an address that is currently a string, and you suddenly decide that, okay, it doesn't need, it can't be a string, it has to be a value object with 3 or 4 properties. Such a change could require major changes in many other parts of the application. Whereas if you were doing this with CQRS and event sourcing, this change could be completely engulfed within the domain object itself, and the change from that single line to a multiple line, that change could then be updated in the denormalizer and the UI at a much later date, as long as the domain object creates the event accordingly, as it had been doing in the past. Now, with CQRS and event sourcing, only aggregate roots get fed commands, and aggregate roots take actions necessary so that events are generated. Now, there is no way that the outside world, i.e. the UI or the read model, or the denormalizers, would know how the aggregate root is handling a command. You can change the internal class structure or the class relationships in the domain without anyone outside of the domain knowing about it. So you could potentially have messy, tightly coupled code within the domain to start with, and then you could refactor that to make much cleaner and nicer code, while the outside world, stuff outside the domain, the denormalizers, the UI would not have to change. And if they needed to, they could change in the future, but the domain can be refactored without breaking everything all in one go. So you would be maintaining aggregate integrity. Getters and setters are an anti-pattern. We've all heard this, and this is one of the reasons why they are an anti-pattern. Getters can be sometimes necessary in CQRS, but in event sourcing, your domain objects will never have any public getters or setters. They don't need it, and they're of no use. So you are also avoiding an anti-pattern and shielding the rest of the application from changes in the domain by using CQRS and event sourcing. If you want more info on these topics, check out cqrsinfo.com, ncqrs.org, Greg Young's blog posts on codebetter.com. I'd really recommend reading Udi Dahan's clarified CQRS post. It would really help clear out a lot of confusion that many of you may have. Check out Mark Nijov's Trojan solution. It is a much larger, more complicated sample than a simple contact manager or Twitter clone. My website is heartysoft.com. I will probably be posting some articles on these topics in the near future. If you have any questions or you want to contact me, my email is ashik@live.com and my Twitter is @ashik. That's the end of the video. Thanks for watching. Bye.